Hello and welcome to Foundations for Algebra, Unit 3A, Lesson 3. Our objective today is that scholars will estimate square roots and place them on a number line. We talked about the fact that all real numbers can go on a number line, and today we're going to do that. We are going to place these numbers on the number line. So first thing we need to think about is, how do we find square roots? Remember that you should be filling in your notes. We could use a calculator. We could estimate them using known perfect squares. So those are different options we have. So on the calculator, depending on what type of calculator you're using, you're going to find the button that looks like that square root symbol. And then you're going to put the number inside it and hit equals. Some calculators are going to want you to put the number first and then push the square root button. So you're going to have to check your calculator and see what it does. So when I put this into my calculator, I get a value of 7.07106781186, and then my calculator runs out of room. So this is an irrational number. But the calculator doesn't give you the dots. It just sort of stops because it doesn't have any more space to display. Usually you'll be told to either round to the nearest tenths place, which is right there, that 1 digit past the decimal, or sometimes the nearest hundredths place, that 2 digits past the decimal. So 50, the square root of 50 would either be 7.1, because when we round to this place, we look at the one next to it, and we say, okay, 7, we're closer to 7.1 than to 7.0. Or if you're rounding to the hundredths place, it'll be 7.07. So you have to pay attention to what they tell you to round to. One other quick thing to note, I know you guys saw this in Lesson 2 on your Mobius, but the square root of 4 is not just 2, it is also negative 2. Because 2 squared is 4, but negative 2 squared is also 4. So when we talk about the square root of 4, we get the answers 2 and negative 2. Normally, we only talk about the positive one, especially when we're talking about these being in real-world situations, but there are actually 2 square roots. Same thing with 9. The square roots of 9 are not just 3, but 3 and negative 3, because, again, negative 3 squared equals 9. So the square root of 9 is 3 and negative 3. Something to keep in mind. Okay, so now let's talk about these. What are perfect squares? And this, again, is in your notes. I gave you actually this entire table. So perfect squares, we know that the square root of 1 is a perfect square. Its square roots are 1 and negative 1. 4, 2 and negative 2, 9. So you see all these perfect squares going all the way up through, I go up through 15. Okay, now after that, some of these are just ones that you should know. 400, it's a 4, but also 100, so it's 20. 900, 9 and also 100, it's 30. So 1600 would be 40. 2500 would be 50, so on and so forth. Also, they like to do some of these ones with fractions. The square root of 1/4 is 1/2. It makes a little bit more sense if we look at it like this. The square root of 1/4 is 1/2. If I do 1/2 times 1/2, we get 1/4. Same thing if you look at the next one, the square root of 1/100, it's 1/10. And again, when we have 2 perfect squares, the square root of 9/25 would simply be 3/5, because the square root of 9/25 is 3/5. Makes sense if you look at it that way. Okay, so we're going to use these perfect squares. Let's talk about that. So how can we use these perfect squares to estimate the numbers? Now, you have this number line in your notes, and it is a drawing, so you can add to it. So one thing I know right here, on my number line, I see I have my 1. Well, 1 is also the same thing as the square root of 1. 2 is the same thing as the square root of 4. 3 is the same thing as the square root of 9. 4 is the square root of 16. And so, ooh, that was really bad drawing. Let's go take that. And actually take all these back and put them at the bottom. Okay, so 1 is the square root of 1. 2 is the square root of 4. 3 is the square root of 9. 4 is the square root of 16, and so forth. So you can see all of these. And I'm putting these here so that it makes more sense when I start trying to put these other square roots on here. Okay? So I'm putting all these perfect squares. 9 is the square root of 81. 100 is the square root of 100. Or sorry, 10 is the square root of 100. So now, let's look at where will we put the square root of 20. Well, the square root of 20 would be between the square root of 16 and the square root of 25. So I put the square root of 20 right between. Well, what about the square root of 50? The square root of 50 would be between the square root of 49 and the square root of 64. It'd be really close to the square root of 49. We saw that earlier when we did it. So I put that right here, the square root of 50. Well, what about something like the square root of 6? Well, it would be between the square root of 4 and the square root of 9. So here's my square root of 6. And so on and so forth. If I want to put in the square root of 75, it's going to be between the square root of 64 and the square root of 81. And finally, the square root of 90 would be between 81 and 100. Well, what if I asked you, how many integers are between the square root of 6 and the square root of 90? Well, I'm just going to count these integers. I have 1, 2, 3, 4, 5, 6, 7 integers between those two. Okay, let's go to doing this a little bit differently. So we can also estimate these without a calculator. So let's look at the square root of 70 without a calculator. So what you have to do is find the perfect square roots above and below it. So the square root of 70 is in between the square root of 64, which is 8, and the square root of 81, which is 9. So we know our answer is going to be between 8 and 9. So we have to figure out where it is between 8 and 9. Well, I know 70 is a little bit closer to 64. So now let's find what is the total distance between 64 and 81. Well, that's 81 minus 64. When we do that, we find the total distance between these is 17. After you've done that, you're going to find the distance between the lower number and the one you're trying to find. So 64 is my lower number, 70 is the one I'm trying to find. So to get from 64 to 70, it's simply 6. All you're going to do then is you're literally going to take this number and divide it by this number. So it's going to be 6 over 17. This is finding the decimal portion of my 8, of my square root here. So it's going to be 8 point something. And to find out what, I do 6 divided by 17. So long division, 6.00 divided by 17. So 17 goes into 60 twice, 3 times, 30, yeah, 3 times. 3 times 17 is 51, subtract it. I get 9 and a 0. So 17 goes into 90 5 times. 5 times 17 is 85. It doesn't matter, so I know that that's 0.35. So I know that it's going to round up to 0.4. And when or if we're doing this without a calculator, they never make you go past the tenths. So one more practice. What is the square root of 18? So the square root of 18 is between the square root of 16, which is our perfect square, below it, and the square root of 25. So it's going to be 4 point something. So next we need to find the distance between 16 and 25. So to get from 16 to 25 is a distance of 9. Then we have to find the distance between 16 and 18, which is 2. So I know that it's going to be 2/9. Again, I'm going to do my long division. I have 2. I'll get 2 point. I'm going to give myself 2 decimal places. 9. 9 goes into 20 twice. I subtract 18. I get 2. Bring down the 0. I get another 2. So that's going to be 0.222 forever. So it'd be 4.2 is my answer. Okay? Keep on doing these, and I will see you in class.